Unit 6B, Lesson 3. In this lesson, we're going to discuss two-way frequency tables. Two-way frequency tables simply organizes data. If we understand how to use them, it makes solving certain probabilities really quick and easy. So here's a quick run-through of what a two-way frequency table is. It's just a visual representation of the possible relationships between two different sets of data. In this case, we would be comparing males and females to their preference of a type of vehicle. Okay, so we could see the number of males that like a sport utility vehicle, the number of males that like sports cars, and then we see the total number of males in the survey. We see the number of females that like a sport utility vehicle and the number of females that prefer a sports car and the totals along the right side for the number of females in the survey. If we add the total number of males and females that like sport utility vehicles, which was 156, and the total number of male and females that liked a sports car, which was 84, if we add 156 and 84, that total is 240, which is the same as if we would take the number of males plus females, 60 plus 180 would get 240 as well. So you can just see there's a quick way that we can organize data, and if we're trying to find the probability that a male is going to prefer a sports car, we could use this information to find that probability relatively quickly. Next, we're going to go through a few examples of where we use a two-way frequency table to find some information. So in this example, data was collected about jogging from students with two older siblings, and that is shown in the table below. We can see along the left side, student does not jog versus the students that do jog. And then across the top, we can see what their siblings did. So in this case, neither sibling jogs, one sibling jogs, and both siblings jogged. And then we can see the amounts from that survey that are in each category. So what we want to determine in this survey is whether a student with two older siblings is more likely to jog if one sibling jogs or if both siblings jog. Then we're going to justify our answer. Basically, we're just going to show the probabilities for each situation and compare the results. So there's two types of probabilities we have to calculate in this problem. First, we have to calculate the probability that a student jogs given that one of their siblings jogs. And then the second probability we have to calculate is the probability that a student jogs given that both siblings jog. For the first probability, the probability a student jogs given one sibling jogs. So now we're only going to focus on this column where we have the data for one sibling that jogs. The number of students that do not jog is 1,823. The number of students that do jog is 416. So to find the total, we would add those two values together, which is where the 2,239 comes from. So now we take the number of students that jog divided by that total, and our approximation turns out to be 0.19 if we go to two decimal places. Now if we use the same idea to calculate the probability that a student jogs given that both siblings jog, now we're just looking at the last column. So we're taking 1,380 plus 400 to get our total. And then we're taking the number of students that jog, 400. 400 divided by that total gives us approximately 0.22. So the probability that a student jogs given that one sibling jogs is 19%. The probability that a student jogs given that both siblings jog is 22%. Now to the last example, we have a survey of a student body at Central High School about their television viewing preferences. So we have the males and females in the total along the left-hand side. Across the top, we have those that prefer a comedy series, drama series, or reality TV series. Using this table and the information, we want to determine, are the events student is a male and student prefers reality series independent of each other? So there's two probabilities we have to calculate in this problem. First, we have to calculate the probability that a student is a male given that they prefer a reality TV series. And then the second probability we have to determine is whether a given student is a male. If these two probabilities are equal, then they are independent of each other. If they are not equal, then these two events are not independent of each other. So first, to calculate the probability that a student is a male given they prefer reality TV, we would only have to focus on the reality series column. So we would take the 70 males over the total, so 70 divided by 180, which is approximately 0.39 or 39%. Then the probability that a given student is a male, the total number of males is 230, the total number of students is 490. When we divide those, we get approximately 0.47 or 47%. Since these two values are not equal, our answer to the question would be no. These two events are not independent of each other.